Hi, welcome to PDNA222 Renewable Power Generation Technologies. I am Dr. Sudhira Navaratna from Faculty of Engineering, University of Peradeniya. Under this course, we are going to talk about the different renewable energy systems. So we will first focus on the performance evaluation of renewable energy systems, and then we will talk about the transition of electricity supply systems in order to adopt a high renewable energy share. And then we will talk about the external cost analysis of renewable energy systems, and then even finally we will talk about the integration of renewable energy systems with multi-generation energy plant. Okay. So we will first focus on the section 1, the performance evaluation of renewable energy systems. And under this section we will look at different types of renewable energy systems available and their technical characteristics, and then we will discuss the performance matrices that we are going to use in order to evaluate the performance of these individual renewable energy sources, and then we will analyze the individual systems like solar, wind, biomass, hydro, the marine energy, and geothermal, and so on, by using these performance matrices. And then we will compare the different energy sources, and we can summarize their performance. Okay. So first what I am going to do is I will give you a very brief overview comparing different renewable energy sources, and then we will go into one by one, and we will discuss their performance in detail. Right. So as I said, these are the energy sources that I am going to mainly focus on. So we will discuss about the solar energy, which is more popular in countries like Sri Lanka due to the high availability of the sunlight, and it offers the high scalability and low operating cost. So this is ideal for the residential and commercial applications. So that's why you can see that even in Sri Lanka, the rooftop solar is very popular compared to the large scale the solar plant. Okay. And the wind energy is also the renewable energy source, and it is very effective when you have a very good windy region, right? So if you have windy regions, the efficiency of this renewable energy system is much higher. It's higher compared to the solar PV. You will see the data in later, and so this the wind is actually more popular in the large scale. So small scale and the distributed wind resources are less, but the large scale ones are more popular compared to the initial cost associated with the wind energy system. The biomass energy produce the energy from organic materials, reducing waste and provide renewable fuel source. Okay. So this is effective for both electricity generation as well as the heating. So you can burn the biomass, biofuel, and then you can produce the heat as well as the electricity. And the hydro energy is the more popular. Actually, if you look at Sri Lanka, we were utilizing hydro energy for decades now, and you can say we are kind of pioneers in hydro energy. We have large scale hydro power plants, the many of them actually providing a significant portion of the country's energy need. And you know that the hydro energy, it generates the power through water flow in the dams and rivers, and it's known for its reliability and low emissions, and it plays crucial role in energy storage, right? And the countries like Sri Lanka, if you look at the Sri Lanka, we have actually harnessed the most of our large scale hydro energy resources available. And now when we talk about the renewable energy systems, we are talking about the small scale hydro energy systems, as well as like systems like runoff rivers and so on. And the one other advantage in the hydro energy is that you can use this hydro energy as energy storage. And the pump energy storages are taking attraction nowadays. People are looking at the ways to store the energy. So one of the ways to store the energy is through this pump hydro system. So we will talk about them in details when we talk about the hydro energy systems. Okay? And the geothermal energy, it extracts the heat from the earth's interior for electricity and heating. It provides the constant energy source with minimal environmental impact. But the technology is still advancing, and it needs a lot of land area. And so because of that, the technology is picking up a little slow in countries like Sri Lanka. Okay? And the marine energy, it captures the energy from the ocean tides and ocean waves. Okay? So this is again emerging technology, and and it needs a lot of initial cost and a lot of technical advancement. So that's why, though we have the sea around the country, we are still at the very early stage of harnessing the marine energy in Sri Lanka. Okay, right. So, and other than these type of energy resources, the next important thing is how to store the electricity. So one of the ways, as I said, is by using the pump hydro, and there are other different types of ways. You can use the battery systems, as well as you can use the hydrogen to store the electric energy. So you can you can generate hydrogen from the electricity or the renewable energy, and then store it in the tanks, and later you can use the fuel cells to generate electricity from this hydrogen. So we will also discuss about the hydrogen energy systems in detail later. Okay, right. So why the renewable energy is important, right? So the renewable energy, it significantly reduces the carbon emission, and it helps to combat the climate change. So that's why the people are demanding more and more renewable energy compared to the traditional energy sources such as coal and natural gas and so on. Okay, and the energy security, there is another the factor. Okay, so you have diverse renewable energy systems, solar, wind, biomass, and so on, which basically enhance the energy security by reducing the dependence on fossil fuels and volatile markets. Okay? And the people are looking for a sustainable future. Okay? So the transition to these renewable energy resources is essential for sustainable development, ensuring the resources for the future generation. So you have to make sure you leave adequate resources for future generation. So the sustainable utilization of the resources are very important. So the renewable energy systems like solar and wind provide the sustainable energy generation. Okay? And there are various economics benefits as well. The investing in renewable energy creates jobs and stimulates countries' growth, and it helps the development of local community and so on. So there are various types of schemes adapted in this renewable energy generation. Like for an example, we are talking about the community grids in some time. So which is basically use the renewable energy generation uh, to uh, uh, to form a small microgrid which is basically operate and maintained by a certain community, which is then that's why it is called the community grid. So which will create the job opportunities for the community, the responsibilities for the communities, and it will create leaders out of the community and so on. So there are various impacts other than generating the electricity or generating the energy requirement. There are other various impacts on this renewable energy utilization as well. Okay? So in order to do in order to meet the energy requirement and in order to generate the energy requirement, the technologies needs to be advanced, right? So for an example, if you take a look at the PV systems, the current efficiencies of the PV system is between let's say 15 to 22% and so on, right? So the technological advancements need to be happen in order to increase the efficiencies and so on. So a lot of research are going on in these areas. So how to improve the efficiencies and performance of the different renewable energy resources such as solar, wind, and other different types of renewable energy sources. Okay? Right. So before we move on to the performance analysis, let's have a brief understanding about how the world runs. Okay. So here I have given you the world renewable energy utilization. Right. So the world energy requirement in 2023 was totally 183,230 terawatt hours. Okay. So this is the energy requirement, not just the electricity, but energy for heating, cooking, and various other tasks as well. Okay. So if you look at the how this energy is harnessed, right? So you can see about 54,500 terawatt hours was harnessed from oil, taken from oil, right? So this is including the transportation as well, right? So the vehicles. So vehicles use gasoline, the diesel, the petrol, and so on. So oil has the major contribution in the world's energy requirement, right? And then for generation, the power generation, we basically depends on the coal. The world is basically depend on the coal. So you can see 45,500 terawatt hours is coming from coal, right? And for about 40,000 terawatt hour is coming from the natural gas, and about 6,800 terawatt hour is coming from nuclear, right? So if you look at the contribution from the renewable energy sources, the hydro contributed the most because it contributes to lots of electricity generation as well as the other energy needs as well, right? So you can see that around 11,000 terawatt hour is supplied by the hydro, and wind energy supplies about 6,000 terawatt hours, the solar about 4,200 terawatt hours, and the biofuel because it's for both the heating and the electricity generation, so it supplies about 11,000 terawatt hours. Okay? And then the 2,500 so terawatt hour is coming from the other different renewable energy sources. Okay? So if you carefully analyze these numbers, you can still see that the about 75%, a little more than 75% of the energy requirement is supplied by the non-renewable energy sources in the world, right? So that's why the different countries has set up their sustainability goals. So in order to facilitate the transition from the non-renewable sources to the renewable sources. Okay. Right. So let's take a look at the power generation, the electrical power generation. So the total the world electrical power generation is in 2023 was 28,844 terawatt hours. Okay? And out of that, the 10,200 or 10,300 terawatt hours was produced by the coal, and 6,582 terawatt hours was produced by the natural gas, and oil being mainly utilized for the transportation. Only 849 or 850 terawatt hours is for the electricity generation, right? And from the nuclear, it generates like 2,640 terawatt hours. Okay? And again, if you look at the renewable energy contribution, so you can see the about 4,298. So 11,000 for total energy. Out of that, about 4,298 terawatt hour is coming from the electricity generation. Okay? And the wind contribute to 2,300 terawatt hours, and the solar 1,641 terawatt hours. And the biofuel, you can see it's mainly going for heating and cooking and so on. So the electricity generation is less from the biofuel, so it's only the 1,280 terawatt hours of electricity generation was happened through the biofuel. And you can see the geothermal is very small, and the hydrogen is emerging technology. So it's still the application wide still not matured. So we have to see what's the future of the hydrogen later on. Okay. Right. So okay, so now again, if you look at the contribution for the renewable energy resources for electricity generation in 2023 in the worldwide, you can still see that it is about 25% or little more than 25%, but the majority is coming from the non-conventional or non-renewable energy resources. Okay? So that's why, as I said, the people have set up various goals like the various sustainability goals, as well as various targets like the carbon neutrality targets. So for an example, Sri Lanka has set up its carbon neutrality target to achieve in 2050, right? And including various other countries. And countries like China, they have set up their target to 2060 and so on. So to achieve this carbon neutrality, even in the electricity generation as well as the transportation system and various other energy requirements, so we have to move from the non-renewable energy sources to the renewable energy sources. Okay. Right. So now in order to see the possibility of this transition, we have to analyze the characteristic of renewable energy system. So we are going to analyze their efficiencies and their costs, associated costs, the initial cost, operational and maintenance cost, and so on, and their environmental impact, and then the sustainability and the sustainability goals that you can achieve by utilizing these renewable energy sources and so on, as well as the technological maturity. So this is most important one. So how mature the technology and how the technology is developing. Okay. So in order to analyze the performance of these systems, we are going to look at various performance matrices. So I have listed some of them here, and we will come up with some others time to time. So we can look at the energy output, which is a measure of energy produced by each renewable energy source, and it is critical for efficiency assessment. So we can assess the efficiency by looking at the energy output and the energy input, right? And we are also going to look at the carbon footprint, right? So which is the one of the major parameter that we are going to evaluate the greenhouse gas emission of each system, okay, which basically says what is the environmental impact of these different renewable energy sources, okay. And another important parameter is the cost associated with these different types of renewable energy sources. So initial cost or the capital cost is the one, and then also you have the operational and maintenance cost. So the cost analysis needs to be performed in order to understand the feasibility, understand the scalability and so on of these different types of renewable energy sources. Okay. And then the performance measure that we can utilize is the operational efficiency. So this measure how effectively each system converts resources into energy. Okay. And and it's also discussed the long-term viability and the availability, and how the efficiencies are increasing, and how promising these different technologies are, and how likely these technologies to be adapted in the future. Okay. Okay, so those are different performance matrices that we are going to evaluate throughout this discussion. So the next what I'm going to do is I'm going to compare different energy resources in terms of these performance matrices to give you an overall understanding, and then we will look at individual energy resources, and we will have a little bit in-depth analysis of their the performance, including the efficiencies, the installation costs, and the technological advancement, and so on.